So here what we have done is we have connected the L293D driver IC to our Arduino, and we have also connected a switch in pull down configuration in order to control the direction of a DC motor. So first we will see a unidirectional control of DC motor, so that the motor will rotate only in one direction. Okay, so for that we'll try to draw a truth table. Fine. So in our truth table we have switch as input. Okay, so we write uh, switch as input, and that is connected to A0. Okay, so we'll just see how this switch is going to work. So if I open close when the switch is in open condition, okay, the A0 pin is now connected to ground, so we get a low signal at A0. So we'll write low here. Okay, when switch is open. Okay, when switch is open. Okay, when switch is open, we get a low signal to pin number A0. And as we close the switch, this plus 5 volts get connected to A0. So when my switch is closed, okay, when I close the switch, okay, the signal at A0 will be high. Okay, so I will write HIGH here, high signal. Okay, now let us keep an aim that when I open the switch, my motor should, okay, I write motor here, M for motor, my motor should stop. So I write stop here. Okay, when I open the switch, my motor should stop, and when I close the switch, my motor should run. Okay, my aim is that. So what my aim is, as I open the switch, my motor should stop, and as I close the switch, my motor should run. Fine. So, and we know that, okay, in order to rotate the motor in any direction, say clockwise direction, we have to send high signal to IN1, low signal to IN2, and enable we should set it as high. So the pins that I've used here as an output is pin number 11, pin number 10, and pin number 9. So in order to rotate the motor in say clockwise direction, we have to set pin number 11 as high. Okay, so I write high below pin number 11. Pin number 10 should be low. I write low here, and pin number 9 should be high. Fine. So this will rotate my motor in one direction. As of now, here we'll rotate the motor in clockwise direction. Another my aim is to stop the motor. So in order to stop the motor, I just have to send low signal to pin number 9. So I write low here, and this can be high, and pin number 10 can be low. Fine. So this way, looking at the truth table, we can now write the program. So how we can write is, whenever your A0 pin is low, we send high signal to pin number 11, low signal to pin number 10, and low signal to pin number 9, so that our motor stops. And whenever the signal at A0 is high, that means our switch has been closed. Okay, at that time we will send high signal to pin number 11, low signal to pin number 10, and high signal to pin number 9 in order to rotate the motor in clockwise direction. Fine. So let's go to programming now. Okay, now let's see the programming part. Since we are using pin number 10, 9, and 11 as output, so we declare them as output under void setup, and our A0 is the input pin where we have connected the switch, so we declare it as an input pin. So our first job is to read the input pin. Okay, so for that we initialize the variable A, and we read the A0 pin. Fine. Now, as per the condition we have done in truth table, or as per our aim, when our switch is open, motor should stop. So accordingly, okay, we have drawn the truth table like when A0 is low. Okay, so we may keep the condition as when A0 is low, we have to send high signal to pin number 11, low signal to pin number 10, and low signal to pin number 9. So accordingly, we'll write a program digital write 11 high, digital write 10 low, and digital write 9 low. Right? So this should stop our motor because pin number 9 we have connected to enable pin. So whenever enable pin of L293D is low, we won't get any output, so motor will stop. Right? In another case, we have when A0 is high, we have to send high signal to pin number 11, low signal to pin number 10, and high signal to pin number 9 in order to run the motor. So accordingly, we have written the program. Okay, and let's see how our circuit is going to work. Fine. Since our switch is open, our motor is stop. Motor is in stop condition. Okay, as per our aim, when switch is open, motor is in stop condition. Fine. So as I close the switch, now my motor will rotate in clockwise direction. So as our aim is there, okay, we have fulfilled our aim. Like when switch is closed, motor will run. When we open the switch, motor will stop running. Right. Now here, since the motor is running in clockwise direction, if you have to rotate the motor in anti-clockwise direction, okay, what we'll do, we'll just change the signal at pin number 11 and 10. So if we make 11 low and 10 high, okay, our motor will rotate in anti-clockwise direction. We'll keep 9 as high, okay, since we have to rotate the motor. So accordingly, we'll make the changes in the program. Right. So in program, what we are going to do is we'll just change this part. We'll make pin number 11 as low, okay, and pin number 10 as high, okay, in order to rotate the motor in anti-clockwise direction or the counterclockwise direction. Right. Then let's see. Since our open condition motor is in stop condition, it's fine. As we close the switch, now my motor is rotating in anti-clockwise direction. So a small change in signal at pin number IN1 and IN2, we can rotate the motor in another direction or the clockwise direction. Fine. I hope you have understood. Okay. Till this point, this can be called as unidirectional control of DC motor, either clockwise or anti-clockwise. Fine. Next, we'll see the bidirectional control of DC motor. Okay. And also we'll see how we can control the speed of a DC motor using PWM techniques in our upcoming videos. Thank you for watching.